All right, talking about specific heat. Specific heat is a intensive physical property, because it is specific to any certain substance. Every single substance has its own specific heat. What is specific heat? It is the capacity of a solid or liquid to raise their temperature 1 degree Celsius, the amount of heat needed to raise 1 gram, 1 degree Celsius. 1 gram, 1 degree Celsius. It is the measure of the heat value required to do so. And like I said, every individual substance, whether it's an element, a compound, a mixture, whatever it is going to have its own specific heat value. So similar to density, it can help identify the substance. Now, let's look at this scenario and try to think about how applicable specific heat is in different scenarios. Imagine you go to the beach on a hot day, you step on the sand with sandals in your hand, and it's hot, of course. This could also be applied to, like, say you're going to the pool and the asphalt around the pool is also really, really hot. Same idea. You start sprinting towards the ocean to cool your feet down, of course, and then you step on a flat piece of copper metal. The flat piece of copper metal does not cut you or anything, but it is even more hot than the sand. And we're going to talk about why that is in just a minute. And then you finally get to the cool water. That's why it says burning hot, because the metal is really, really, really hot. I'm sure you already know that if you let metal sit out in the sun, they get really, really hot. You finally get to the cool water. Couple of things going on here. The sun's beating down on the metal and on the sand, and it's absorbing some of that heat, especially if it's on a hot summer day where it's maybe in the 90s, absorbing a lot of that, and it's raising its temperature, and that's why the sand is really, really hot. However, the copper metal absorbs more, raises its temperature even more. That's why it's burning hot at this point. Metals have really low specific heat, so they absorb energy and their temperature changes very quickly. Sand, kind of in between, still absorbing a lot of energy because it's really hot, but not as bad as the metal. And then, of course, you get to the nice, cool ocean water. Water has a really high specific heat. Very, very high specific heat, so it absorbs lots of energy before it actually changes temperature. Now, specific heat of water and copper, let's compare, because this kind of goes with that example. The specific heat capacity of water is 4.18 joules per grams degree Celsius. This means that the water absorbs, technically you can go with 4.18 or 4.184 depending on what they give you in the problem. Technically it's 4.184, but a lot of times we just go with the 3 because it's easier. You need 4.18 joules of heat in order for 1 gram of water to increase 1 degree Celsius. That actually is quite a lot of energy. Now copper, on the other hand, copper specific heat is 0.385 joules per grams degrees Celsius. So you don't need very much heat here to raise the temperature of the copper. Copper has a low specific heat. The water has a really high specific heat. Copper changes its temperature almost immediately, and the water does not. Metals, along with copper, fall into this category of being good conductors of heat because they can absorb and change their temperature and conduct the heat very quickly. So the low specific heat capacity, that not only goes for copper, it goes for most metals, because you know that they are good conductors of heat. So that brings us to our next scenario. Say you're going to make some pasta, right? We need boiling water. So you have your pan, your aluminum pan, you fill it with some water, okay, and you turn it on. Now, you touch like the top of the pan where it's just the metal, within like 30 seconds to a minute, it's almost instantly super hot and will like burn you, and you'll leave you a mark there. So a minute to 30 seconds, that pan, the part that's not touching the water is super, super hot. Now, if you were to take your finger though within 30 seconds to a minute and put your finger in the water in the pan, it's not even going to be probably lukewarm, just a little bit above the tap water temperature at that point. Okay, the water's going to take a while to boil. Takes a good like 10 minutes to get it going. You got to add a lot of heat to do that. Why do you have to add a lot of heat to get the temperature of the water up, but the aluminum pan immediately goes up? Well, the aluminum, being a metal, has a low specific heat. So the metal, the aluminum, that's going to have a low specific heat. And the water is opposite. It has the high specific heat. Now, this also goes for the oceans. We were talking about the ocean example. And this is why I do not go to the beach in June. If I'm going to the beach, I'm going to go in August or late July, because the ocean water takes a good couple of months to warm up. So you go to the ocean in June, the water is really cold. Really, really, really cold. So in July, August, it's a lot warmer, a lot more tolerable to go around here. Now, you're going to like the panhandle of Florida, which is also really nice. You can still go to the beach down there until like the end of October, because the water's still super warm. But also, which is pertinent to what's going on, because we've had a couple of these this year, that's also why they get lots of hurricanes still through the fall, because the Gulf water is still really, really, really warm. And the storm feeds off the warm water and is able to keep going and intensify and other things like that. So a couple little like applicable tidbits here. We're talking about specific heat. All right, so there's an equation for specific heat. We call it Q equals MCAT. It's really MC delta T, but we call that MCAT for short to make it easier to remember. What do these mean? Q is the heat absorbed or released. M is the mass of the substance. C is the specific heat capacity. And delta T is the temperature change. Now, if you've ever seen in math, a delta like this means change of. So this is the change of temperature. And when we use deltas here in chemistry, it's always going to be the final minus the initial. Okay? Final minus initial, yes. That triangle symbol means delta. It is the Greek letter, the uppercase Greek letter for delta. And you'll see it a lot in math classes and chemistry and physics. We do lots of change of type equations. Now, the units for Q. Q is going to be a measurement of heat energy, and heat energy is in joules. So we use J for joules, okay? So write a J next to that so you know we're going to be measuring the Q value. The heat absorbed or released is going to be measured in joules. That's the metric system unit for heat. You might see calories out there, sometimes calories out there, but that's not the metric system unit for heat. Mass for this equation is always in grams. So it's going to be a G there. So if you're given like kilograms, or if you're given like centigrams or something different, you have to change it to grams first before you can use the equation. Because this is always designated as the amount of heat per gram, 1 degree Celsius, so it has to be in grams. The C value is a derived unit. It is joules over grams times degrees Celsius. So you have the top unit is joules. You have 2 units multiplied on the bottom. This is the derived unit, joules per gram degrees Celsius for C, for the specific heat there. Okay? And last but not least, delta T, or temperature, here is going to be done in Celsius. So we will not be using Fahrenheit, we will not be using Kelvin, we will be using Celsius for this equation always. And the units matter, they're important, but I'm going to show you how to cancel them as we work through the problems. All right, so first example here, how much heat is absorbed when 500 grams of water, C is 4.18, goes from 25 degrees to 35 degrees. So the first thing to do here, write out your equation and figure out what you got in the word problem. Like this, 500, and don't forget to put the dot there. I know it wasn't in your notes, so you put that in there. I'm on 3 sig figs, so I made it 3 sig figs. 500 G, which variable is that? That's M, that's mass. So you can label as you go, that's M. This one already tells you this one's C, this is the specific heat, so you already know that. What's 25? Initial temperature, TI, and 35 is TF, right? Okay, so which variable are we missing and solving for? You look here, we're missing Q. We don't have the heat, so we're going to solve for Q this time. Then all you have to do is plug in the numbers, substitute them in, we call it plug and chug, and get your answer. So we put the 500 grams here for the mass. We put in the 4.18 joules per grams degrees Celsius in here. That's for the C. Delta T, I'm going to start with my final temperature first, T final. So 35.0 Celsius, 35 degrees Celsius minus the 25 degrees Celsius, like so. And this is all going to give me Q. Now I want you to watch how the units are going to cancel. So the grams cancel with the grams here. The Celsius cancels with the Celsius. So what are we left with? Joules. So Q, of course, is measured in joules. It is a heat energy, so it needs to be given a heat unit, which happens to be joules. Now, what do we get for our calculator answer for Q here? Let's do that. Let's calculate that. That is correct. 20,900 joules. If you multiply it, check it, make sure that you're getting that answer in your calculator. And look how nice that is for us. If we're going to be calculating with sig figs, since this is multiplying, dividing here, we're going with 3 for this one, 3 for the temperatures, 3 for the specific heat. So we're going to keep 3, and look, it gave it to us in 3 already, so we didn't have to change it. That was very, very good. Nice. And yes, that Q number should be a large number. It should come out as being a large number. And we got it right. So let's take a look at the next one. Try to set it up real quick. Try to identify the variables. Figure out what's missing. What are you going to solve for? I always start with your equation. Q equals MCAT. As you read through, identify. That says grams. This must be mass. This already tells me specific heat is C. And here, 245 joules. Which variable is that one? That is Q. Very good. So what are we missing then? We are missing the delta T. That's what we're solving for. Very good. We want to know how much it goes up. Now all we have to do is plug in and calculate our answer. So 12.5 grams times 0.90 joules per grams degrees Celsius. And delta T, we don't know. So I'm going to leave that as the variable. And over here for Q, I plug in my 245 joules. Now once again, watch how they're going to cancel. Joules cancel with joules. Grams cancel with grams. So what is our unit left over? The Celsius, which makes sense because that is a way of measuring temperature. All you have to do is take your 245 and divide it by these two numbers, right? If you're doing regular algebra here, solving for delta T, move those things that are multiplied over to the other side by dividing. So what do we get for delta T? What's the calculator answer?
21.7.
21.7. What? Repeating. Okay. Good. Now, let's look at what we got up here. How many sig figs in that guy? 3. How many in this measurement? How many in that one? 2. So what should we go with? 2. So keep the 2. What do you do to the 1? Round it up. So we end up with 22 degrees Celsius. Very, very good. Which is the correct answer. Question?
For practice, now it says 500 grams. Technically, we say this really well.
But I told you to put the decimal point in there?
Okay.
Yeah. Because I wanted it to be 3. Yeah. All right. Here. Water has a specific heat capacity of 4.184. This time they want us to use the full out number. Sample needs 15,675 joules to heat it from 0 to 75. Determine the mass. So it's the same thing. This time we're solving for M. Right? These are pretty much the only variations you're going to have. This is your C. This is your Q. Here is your TI and your TF. Q equals MCAT. Like so. Let's plug these in. We get Q. We have the 15.6 joules. We're missing the mass. We have the 4.184 joules per grams degrees Celsius times our 75 minus our 0 degrees Celsius. Joules cancel with the joules. The Celsius cancel with the Celsius. And lo and behold, we're going to get grams out of that. So what is the mass here? What did we get? What is our calculator answer? Somebody give me that. This one's a little tricky to round. 49.95, I believe, yes. Okay. Now, how many significant digits are we allowed here? 2 based off of this temperature, right? So, gonna keep the 4, now we have to round the 9. We're gonna have to round up this 9 to a 0, which rounds this up to a 5. So it's gonna be 50, and then if you just put a dot there, that makes the 0 significant, and put the G. Or, if you don't like that, you can write it as 5.0 times 10 to the 1 grams. So you could do that either way, and you would get the correct amount of significant digits. Yes?
You only put 75 minus 0 degrees Celsius. Why isn't there a degrees Celsius next to 75 when it's in the problem?
Well, because both of them are together in that parentheses with the same measurement.
Gotcha. Okay.
Good question. So I was just trying to be a little shorthanded there. All right, last problem. This one, we've solved for Q, we've solved for delta T, we solved for M, so this one's going to be solving for C, as you can see. This is pretty much the variation of the problems you're going to get. That's it. There's only 4 types you can possibly get because there's only 4 variables to solve for. All right, so what's the little glitch here, though, before we begin? We have kilograms, yeah, so we have to do a little conversion quickly here. So how many grams is that gonna be? Good, because we're gonna move it over 1, 2, 3, 155 grams, because remember, changing kilograms into grams is like multiplying by 1,000. Now we have the correct grams, we can plug into our Q equals MCAT. And we get here. Our grams are 155. We're missing C. Delta T. This is T initial. This is T final. So we do 25 minus the 9. Okay, and we have our Q value, which is 5,696 joules. Now you'll notice here that none of the units are going to cancel. That's why they're all going to be a part of the specific heat. So we're going to be dividing this side by the grams and the Celsius. That's why those units go on the bottom. So what is our specific heat here? Our calculator value? 2 point what?
4068.
Are you sure? I was gonna say 2.2, 2.296. Okay, that's what I was getting. Just check your numbers real quick. All right, now
Oh, yeah.
What exactly did you do to get C?
you have to divide the 5,696 by the 155 and by this difference. Like solving for C, isolating, you move the other two to the other side by division. All right, now for significant figures, it looks like we should have 3. So let's keep 3, keep the 2. What do we do to that 2? Or I'm sorry, what do we do to the 9? We have to round that up to a 0. That's going to round that up to a 3. So we get 2.30 joules per grams degrees Celsius. All 3 units go on the C, like so, as you can see.